For this question, a continuous random variable y has a probability density function. So this is a small f as follows. So for continuous random variable, we draw out our interval 0 until 1. Our function will be ky and then 1 minus y squared. Then for the first part, showing that k is equals to 12. So in continuous random variable, we know that total probability is supposed to be equals to 1. So in continuous, their probability will be represented by its area under the graph, which is 1. Therefore, to find the area under the graph, we need to integrate 0 until 1 for this function. Then we respect to y equals to 1. So take notes here, our random variable using here is y, so don't write your x. Then we're going to find k. So to integrate this, we need to simplify first. Where k is a constant, we can factorize out. And then for this, 1 minus y squared, we can expand. It becomes a squared and then 2ab and then b squared. And we do the expansion one more time for y minus 2y squared, then y cubed dy. So after we expand everything, then the function inside here, they are ready to integrate. So to integrate this, power plus 1 over new power. Then we substitute our upper limit 1 minus lower limit 0. So when we substitute 0 anything, it will become 0 also. So to simplify this, we can get 1 over 12k. So therefore, k will equals to 12. So we shown this answer. Then for part B, it asks us to find the probability that at most 0.6 at most means y will be less than equals 0.6. So we need to integrate start from 0 up to 0.6 for this function. So k is 12. So one more time, we are going to factorize our constant, and y times 1 minus y squared we already expand just now, which is y minus 2y squared plus y cubed. Then we integrate power plus 1 over new power. Then we substitute upper limit 0.6 minus lower limit. Then for question C, we need to find the cumulative distribution function BF for y. So to find cumulative distribution function, we need the interval before the graph, and then the interval involving graph, and then the third step will be the interval after the graph. So for the first step, which is the y before 0, it will be y less than 0, not included. So fy here, we can notice here, we don't have any function to find, we don't have any area to accumulate. So our accumulation, we get 0. Then for the second step, which is y in between 0 and 1, so our fy will be before. So when you come to second stage here, before is 0, currently we need to integrate this. So you need to integrate 0 until y for the current function, which is 12, and then y times 1 minus y squared, integrate respect to y. So similar, 12 constant we factorize out, then we expand this y, it will become y minus 2y squared plus y cubed, as we already expand it in the first stage here, so we can just use it. Then power plus 1 over new power. Substitute the value of y, so it will remain y in the term of y, then minus 0. So finally here we have simplify this, we'll get 6y squared 8y cubed plus 3y4. Then for the third stage here, where it is after 1, so where 1 is not included, y more than equal 1, so our fy will be before that, when you have stage 3 here, before that you have already accumulate your random variable up to 1, then currently we have 0. So before is accumulate up to 1, currently is 0. So we are going to substitute this one into the function before this. So we get 1. Then we're going to rewrite our answer in piecewise. So starting from beginning 0 for y less than 0. Then second answer 6y squared minus 8y cubed plus 3y4 for y in between 0 and 1. And then lastly 1 is for y greater than 1, so not included. Since 1 already included in this interval, so the next interval we will not include the value of 1.